Moving on to our next session, from robotics to quantum computing. Quantum computing, let us understand how quantum computing is shaping up as a technology and the path India is taking. Let's get a view of the current landscape and emerging opportunities in our next session, which is quantum computing and India's path. And for this, I am very pleased to invite Mr. L. Venkata Subramaniam, IBM Quantum Distinguished Ambassador and IBM Quantum India Lead. Please welcome Mr. L. Venkata Subramaniam. He is an experienced leader in artificial intelligence with a history of innovation, a strong researcher who has developed new products and been recognized as a master inventor. He has contributed to several IBM products in speech, text, and vision. Along the way, he has garnered 34 patents and published 150 papers with 3,000 plus citations. A big round of applause for his goal, which is to set up a strong quantum computing ecosystem in India that builds quantum solutions for India and the world. Welcome.
Thank you so much. So I'm really happy to be here with you to talk about how quantum computing is evolving, what is the landscape, and how India is positioning itself in this. So how many people here have used a quantum computer? Okay, does anyone know that you can access a quantum computer sitting right here? Okay, so 2 people, 3 people. You can actually access a quantum computer over the cloud using your laptop or even your phone. You can just access a quantum computer and run your programs on that, okay? So I'll talk about where this technology is going, what is going on in these next 20 minutes. So we're a small world, right? But there are several problems. Recently we saw all these avalanches, extreme rainfall in the hills. We are seeing fires in Canada and many other countries. So there are several things which are happening to Earth which we have to understand and begin solving, right? So I'm going to give you some examples here. So one is, nitrogen fixation. The Earth's population has crossed, I think 7 or 8 billion now. To support this population, we need to do farming. To do farming, we need fertilizers. And fertilizers are one of the most polluting industries. They actually contribute a lot to the carbon emissions. So how can we come up with better fertilizers which are less polluting when you produce them? The other is hydrocarbons, right? So we are burning a lot of carbon, coal, and all of these things. How do we efficiently produce energy? And that's a long-lasting problem because, countries like India are now electrification and usage of electricity is spreading across the world, and that means more electricity, and that means, are you going to burn coal? Are you going to produce better forms of energy? The other is finance, right? So every 10 years, 15 years, the stock markets crash, the global economy goes down, there is recession. In fact, right now we are going through one such, right? Just after COVID, many of the economies went down. Today, a lot of the supply chain is affected. If you go to buy a car, there is a waiting period. So many of these things are problems which we need to be able to solve as we go forward. So, okay, the slides keep moving, but I want to go back a bit. Okay. Yeah. So what is a quantum computer? Okay, so is a quantum computer faster? how many people think that a quantum computer is faster than a classical computer, today's computer? Okay, many people think so here, and it is actually faster. How many times faster is it? On certain problems, it is billions of times faster. Okay, billions. So a lot of for example, on our phone, we use WhatsApp. WhatsApp is encrypted. Most of you know that. The banking transactions that you do are all encrypted. Today's computer cannot break that encryption, but quantum computers in the future will break this encryption. Okay. Why? Because they are so much faster than our current computers that they can break these encryptions. So, of course, we are trying to secure ourselves against quantum computers becoming powerful. But the point is that quantum computers can solve certain problems much, much better than anything else. So here is one example. Okay, so I'm going to talk about coffee. Okay, coffee, as you know, all of us know what is coffee. And okay, I think I'm fighting against the slides here, but coffee molecule, if you try to model it on on our computer, the best supercomputer today, you cannot model it. Okay, why? Because it's so complex. It is complex. Modeling complexity of nature is still not possible for our computers of today, the best supercomputers. And why? Because even if you tried to model it, you would need 10 to the power 48 bits just to represent that molecule. And that's much, much, much bigger than any computer that you can have today. And if you actually try to do it, you would need about 10% of the molecules on Earth to build that computer. Is that even possible? It is not possible. And that's where quantum computers come in. A 160 qubit quantum computer can model the coffee molecule. Okay, and 160 is something which we believe we will reach in the next few years. Okay. So what that means is a lot of the things that we do in labs today, in wet labs today, for example, drug discovery, for example, making fertilizers, for example, modeling coffee, for example, modeling new materials. For example, we just sent the spacecraft to the moon, right? For those spacecraft, what is important? Two things are important. It needs to be lightweight, and at the same time it needs to be very strong to withhold the atmospheric, the speed at which it goes and all of that, so that it does not break. And how do you model this today? You do it in a lab. How can you do it in future? You can simulate it on a quantum computer, right? So now, where is quantum computer moving? Okay, so it started in the year 2019 with 27 qubits. This last year, 433 qubits. If you look at 2022, 433 qubits was released. This year, 1,100 plus qubit quantum computer will become available. Okay. So what this means is quantum computers are improving in power very, very fast. You would have heard of Moore's law. What does Moore's law say? It says our computers double in their performance every 2 years. With quantum computers, what is happening is they're doubling in performance every year. Okay, so there is a parallel Moore's law which is happening in the quantum computing world, which is accelerating that development very, very fast. And that's what you see here, that something in 2019 was 27, we have reached 1,000. This year we are going to reach 1,000. And next year what is going to happen is, we have already announced that by 2033 there is going to be 100,000 qubit quantum computer that is going to be available. And what does this mean? This means that some of the problems which I talked about, like fertilizers, finance, coal, medicine, all of these problems will get solved using quantum computers in the next few years. Okay, so people who are in college today, when they graduate, they're going to be using quantum computers to solve some of the unsolved problems of today, right? So there are problems which we are finding really tough to solve even using the best supercomputers. The expectation is that in the next 5 to 6 years we'll be solving some of these problems using quantum computers. So now, how do you measure the performance of a quantum computer? So there are three aspects. One is the number of qubits, which I told you is more than doubling every year. This year, last year it was 433. It started with 27 qubits in 2019. This year it's 1000. By 2033 we're going to be reaching 100,000, and that's the scale, right? The other is quality. How good are these computers? Today quantum computers are noisy. We want to reduce the noise, right? So that's the other aspect. The third is speed. So if you look at how these things are moving, as I told you, 2019 27 qubits, 2022 433, this year 1000 plus. So the scale is improving very, very fast. The quantum volume, which is the noiselessness, that is also more than doubling every year, right? So you're seeing that quantum computers are improving in their performance year on year, and the speed is also more than doubling every year. Okay, so right now it is at 15,700 circuit layer operations per second, that is CLOPS. CLOPS, yes, and that's moving very fast too. Okay, so now, where are we moving with all of this, right? So I asked you this question: how many people have used a quantum computer? A few hands went up. So I'll tell you that quantum computers can be accessed using your laptop. Right now you can access a quantum computer from IBM, for example, and many other vendors. In addition to that, okay, now it's going backwards. Okay, so to use our today's computer, what does the person do? We all have to learn how to use, for example, Windows or Linux or any of those. To do our programming, we use Python, Java, any of those languages. How do you use a quantum computer? You do the same thing, no change. The same tools, same languages, same code, same computer. You can use your laptop to use a quantum computer and program it. Use the same Python language that you use to program your classical computers. And in fact, if you don't know programming, there are also visual ways of using the quantum computer. So if you just log on to what is called the IBM Quantum Experience, you can start using a quantum computer even without knowing how to program. Okay, so you can just run your programs visually there. So they're very easy to use. So it allows for frictionless development. Anybody who wants to use a quantum computer, you don't have to learn any new skill. All you have to do is get on your computer, log on to the quantum machine, and start using it, right? So it's as easy as that. So there are several models of using this computer. So there are kernel developers, algorithm developers, then there are model developers. So just like in today's world, a developer goes to the computer, starts programming or builds a program to solve a certain problem, in the same way you will use a quantum computer also to solve problems and to build these programs which will run on the quantum computers, right? So in that sense, if you look at it, I will show you some numbers. It is very easy to adopt, and in India that adoption is going up very, very fast. So now, what is the programming language? There is a language called Qiskit. Okay, Qiskit is a Python language. it offers a lot of higher level applications. So for example, if you want to do machine learning, there are libraries there. You use your data, build a program, and call those libraries, right? So it's very simple to use, very easy to use, where you go on the computer, call these programming libraries, and start using them to solve your problems on your data. So for example, if you're a bank and you want to do fraud detection, you want to use machine learning, just the way you use today's machine learning, normal machine learning, classical machine learning, you can call quantum libraries to solve the same problem and compare. You can do the comparison yourself. It's very, very simple for any learner to start using these programs. And this, as I said, using your laptop here at this end, you can use this program, the Qiskit program, to run the backend servers, which are all quantum, right? So it's an interplay between classical and quantum systems, right? So all of these seamlessly work together. So what are the problems that people are solving using quantum computers, right? So there are many. Primarily they are being used in three areas. One is simulating quantum systems, the other is artificial intelligence, and the third is optimization. Examples of simulating quantum systems: chemistry, material science, pharmaceuticals. You're trying to create new drugs. Today, how do you make a drug? How do you make a medicine? You actually take a molecule, put it into a test tube, you see how it reacts, then you give it to a test case of 50 people, see whether they react to that drug, whether it solves, the disease that you're doing. How long does that take? It takes 4 to 5 to 10 years today. In the COVID period, this time period was reduced to 1 year by many of the vaccine companies. Using quantum computers, you will be able to do this simulation much faster. You don't have to do it in a test tube. You don't have to see how that drug reacts in the body. Why? Because you can simulate these things exactly in the way that it happens in your body. The special thing about quantum computers is that they use their computational unit is called a qubit. What is special about the qubit? The qubit behaves like a molecule or an atom in the same way that, for example, the drug reacts with your body, right? So what happens is that reaction, which you can never model on a normal supercomputer, can be easily modeled on a quantum computer. And that's the advantage of a quantum computer. So there are several problems that people solve, and this is a longer listing: improved battery materials, manufacturing defect identification. In fact, many of the things that came in the previous talk also, for example, robotics. In robotics, a lot of the things involve vision, for example. How do you solve some of the tough problems in computer vision are all things you can do using quantum computers. So there are several, customers who have started using quantum computers across the world and in India too. So customers have started to solve actual business problems using quantum computers. I'll give you some examples. So for example, CERN. So this laboratory in Europe which does this molecular level interactions between subatomic particles. Recently, they discovered a particle called the Higgs boson. Okay, this particle explains the origin of mass. Okay, it's a very fundamental particle that was discovered very recently. Just like atoms, molecules, electrons, neutrons got discovered, this was a new particle which got discovered very recently. Now, to search for this through all the, so the Hadron Collider in Europe, it is several miles long. Okay, it's a circular ring where physics experiments are done. So when you do an experiment, a lot of data gets created. And looking through that data to find Higgs boson, phenomena is a very, very tough problem. It is, you can multiply the scale of searching Google by billions of times. Okay, so today Google, what does it do? It indexes all the data that is there, and you run a query and it gives you the results. Now you multiply this problem and increase the amount of data by billions of times. That's the problem you're looking at. And to find this Higgs boson is a very tough problem, and that's something that they're now using quantum computers to solve. Another example is, this one. So what is this? This is the usage of quantum computers across the world. Okay, across the world there are about, this data stops in 2022, but what you'll see there is very interesting. What you see there is India. Look at India. This is people from India using the quantum computers of IBM, across time, right? And if you see, this stops in 2022. There were about 440,000 users. Right now it's crossed 5 lakh users, 2.1 trillion circuits. Out of this, Indians are running one of the highest number of circuits here. Okay, so what this shows is, in this room many people have not used a quantum computer, but among the young people in India, among college students, among the developers, huge number of people are today using quantum computers. In fact, the highest in the world. Okay, so Indians are using, one of the power users of quantum computers today across the world, and the people who are using this are now in the age group of 17 to 25. Okay, so those are the people who are using these computers, very young people, either in college, in fact even in school. Many of these kids are in school who are using these quantum computers. In fact, go and ask your child at home. Maybe the child will tell you, I'm already using a quantum computer. And as you see, this is actually a proud thing for India, that a computing technology that many people in this room have not heard that much about, but across the world, in India, the kids are using this more than anybody else in this world. Okay, so I'm now going to talk about where is India in all of this, right? So I'm going to give you that picture of where is India. You already saw this, that Indians are using quantum computers more than anybody else in the world. Okay, so that's a very good thing, as I said. So where is the talent? It is there in India today. Okay, so that's a McKinsey report which says that European Union, remember, is many countries put together. India is one country. So if you look at any single country, India has the largest talent pool in quantum computing today, right? So Indians, as I said, are power users of quantum computers. They are also, the number of graduates in quantum computing technologies is the highest in India. So in terms of talent, India is really, really very, very strong. Okay, so in quantum computing, in this room, many people have not used it, but if you go out into the colleges of India and other places, you will see that talent, in terms of talent, India is brimming with talent, right? What is the other good thing for India? The second thing is the strong research output. Okay, so this is the number of research publications coming out of different countries. So India, keeps flipping between fourth, third, fourth, fifth every year, So, but what it says is that India is among the top 5, okay, in quantum computing research, right? So that's a very good thing again, because it shows that we are very well poised to take advantage of the quantum revolution that's coming. So how does India needs to prepare for all of this, right? So the processor, I talked about the processor, which is today at 433. Later this year it's going to be at 1000 plus. India is very much slow in this, but we need to speed this up. This is one of the things that we need to pick up on, right, which is the processor. Peripherals, which is, if you see your computer, there is a Intel processor in there, or any other processor, but around it there are so many other technologies, like your hard disk, like your keyboard, like your display monitor. Many things are there to build a computer. Similarly, to build a quantum computer, the processor is one aspect, but there are several other control circuitry around it, and that's another area where India can play a major role, and India can build a thriving peripherals industry going forward, right? The third and fourth, middleware and software and applications, that's where India's strengths today lie, right? Because Indians, as I said, are using quantum computers more than anybody else. They are solving problems. They are actually more expert at using quantum computers to solve problems than anybody else. But the one thing which is lacking is applications, okay? Applications, we are not seeing Indian industry coming forward yet, okay? So in fact, many of you are from industry. What I would urge you is to go and hire some, not even hire, just take one or two interns from those very thriving set of talent which we have. Just start one or two problems in your company. I heard of robotics before us. How can quantum computers help in robotics? If you're from finance, how can quantum computers be applied in finance? If you're from pharmaceuticals, how can it be applied there? So any industry, whether it's pharma, whether it's machine learning, anything, it is for you to now start looking at how you can get ready for the quantum revolution, because it's not very far away. So I'll stop there. Thank you so much.
Thank you so much, Mr. L. Venkata Subramaniam. I would like to now invite Mr. Satya Shekhar Das Mandal, CTO, InfoView Systems Incorporated, to the stage to facilitate Mr. L. Venkata Subramaniam. Big round of applause, please. Thank you so much.